At the very start of the pandemic, the School of Engineering mobilised its expertise and resources to tackle emerging Covid-19 challenges. The school's staff and students have had and continue to have a major impact on the pandemic response. The school's activities have been wide-ranging, from making equipment to protect and monitor key workers, building other examples of bespoke hardware for healthcare, developing new methods of sanitising, investigating the behaviour of respiratory droplets and the effectiveness of masks, tackling problems that affect less affluent countries, and supporting the recovery from the pandemic. In one of the projects that I led personally, a 30-person strong team made nearly 12,000 face shields, which we donated mainly to workers in health and social care. For all of us, it was highly rewarding to be able to make a contribution to the Covid-19 response.
Elevated core body temperature is one of the primary symptoms of COVID-19. It's difficult to measure from ear or orally, but it's very important for key and essential workers to measure their core body temperature remotely and continuously. We have designed a device that goes into the ear and measures core body temperature remotely through an RFID technology. It's completely batteryless and it will increase user adherence. A technology like this will make workplace for key and essential workers safer in a crowded environment.
During the first wave of the pandemic, single-use face masks were in short supply. We received a grant from the Chief Scientist's Office to take a team of engineers and clinicians to produce 3D scanned and 3D printed bespoke face masks. We took this through a clinical trial to test for speech intelligibility, comfort and fit, and now we've started a company to take this innovation to the frontline healthcare workers who need this to help protect them from infectious diseases.
COVID-19 testing can be quite costly, using expensive equipment and reagents such as a PCR machine. And many countries cannot afford that, especially if you need to really scale up. In my lab instead, we use novel enzymes that are affordable and easy to automate, and especially the results are color-coded. So those tools are very flexible, and you can use it in many different communities and parts of the world at an affordable cost. So we are certain that with these methodologies, we will be ready to tackle any future pandemic.
The pandemic has impacted construction efficiency and housing supply in the UK. In this CovSteel project, we tested composite steel frame system and developed efficient structural design scheme to optimize fabrication process and material use in steel buildings. Through collaboration with Scottish construction company, our research outputs help reduce material use, improve construction speed, and to reduce current backlog of construction projects due to pandemic.
The project work is related to the deactivation of live coronavirus. So we've shown that with an antenna system and array like this, we can beam steer microwaves, the microwaves that you would have in a microwave oven, for example, to a specific spot. I actually got the idea when sterilizing my son's baby bottles at home during lockdown. So the idea here is that we can extend this to an ambulance, for example, where it takes 30 to 40 minutes to clean an ambulance by hand. The idea is that we can use a system like this, make it completely automated, and shave the time down to 5 minutes or less. In the lab, we've shown that we can actually kill coronavirus within 3 seconds or less.
This is Edinburgh University's Class 10 cleanroom semiconductor fabrication facility, used by commercial companies and academics. During the lockdown period, we were able to keep open and working shifts, enabling local companies Piraeus and Druck to carry on making oxygen sensors and pressure sensors, which were being used in equipment to fight COVID globally.
At the start of the pandemic, the demand for disinfectants was huge, and Aqualution Systems, who makes these disinfectants, their manufacturing facility was overwhelmed and by a rise in 600% demand. So they got in touch with us through Edinburgh Innovations. We got this project funded, and we made the project in 2 phases with a lab setup, and then we shifted this whole thing into a main on-site setup with big 15,000 liter tanks and high flow pumps. And at the start of the pandemic, when Aqualution was able to make 2,000 liters of disinfectant in one day, at the end of the project we were able to make 12,000 liters of disinfectant in a day, thereby increasing the production and meeting the demand.
In the COVID-19 heat project, we developed and analyzed a survey to provide critical information about the interplay between COVID-19 mitigation measures and heat stress for poor urban populations in the global south. COVID-19 mitigation measures, such as lockdowns, are already hard for affluent populations in the global north, but they can be devastating for poor urban populations in high-density settlements in the global south. The results of the survey are freely available, and we are currently in the process of developing a report in collaboration with the International Red Cross to provide guidance to lessen the impacts of COVID-19 measures and heat stress.
At the beginning of the pandemic, it was not clear whether face coverings would have been effective in mitigating virus transmission. So we apply our knowledge and expertise in aerodynamics to try to figure out the underlying physics and the effectiveness of face coverings. We discovered very quickly that all of face coverings are very effective. However, we also discovered that some of them redirect the flow backwards and sideways, generating a potentially higher risk for some positions, for example, two persons sitting side by side compared to sitting one in front of the other one. And this is the case, for example, of the surgical mask. All of this information were actually helpful for the public, but also for the policymakers.
This video described the huge and varied efforts to help with the COVID-19 pandemic of staff and students of the School of Engineering at the University of Edinburgh. It described the practical contribution that engineering can make to help solve the societal issues raised by the pandemic. I'd like to thank our staff and students for their selfless and in many cases voluntary contributions, which helped so many people, in particular in the early days of the crisis. Thank you all very much.